Good afternoon, everyone. Today we have the second part of the Epanet module, and it is, of course, the continuation of the first one, but this time we are going to run a real simulation, which is much more realistic. We are going to consider the changement on the water demand over the time, over one day. You can see the graph below. You see, in a normal case, during the night, people are not fetching the water, they're not taking shower, they're not working, while the water consumption starts in the morning, stops maybe a little bit during the late morning, start again around 12, and again in the evening. So how to design the water consumption? It's actually very difficult because in normal case, you don't have time to investigate properly. But if you know the local customs, if you know the local behavior of the people, you can estimate a little bit how the consumption is going to be over the day. And on the other hand, no one will be able to tell you that it's totally wrong because there is no a fixed, precise consumption over the time. At the same time, we are also going to consider the pumping time. It is not used to pump 24-hour full time. Usually, you have to give a break to the pump. You might fill the tank for the oil. You might have to make maintenance, and it's not healthy for the pump to run 24-hour. That's why also for the pump, we need to define a pump pattern. And we will now see how to do that on Epanet. Like I've told you last week, Epanet allows only simulation of constant flow. That's why we make several different constant flow and we put them together. And these several different constant flows are linked to the time pattern. And it looks like that. Important for the demand pattern for the water consumption is that the average of the time pattern is 100%. So if we say our people use, let's say 100 liter per day, and we know that they are consuming this 100 liter per day over one day. So little bit, a lot in the morning, maybe a lot in the afternoon, and nothing at night or few at night. So that's why, but at the very end, they use 100 liter. That's why the average of the time pattern must be 100% or 1. So how it works, you have to open the Epanet file that we have done last week, the simple analysis. The simple analysis was just in order to design the network. We ran it, it was working, and the idea is to be sure that we didn't make big mistakes like maybe forgetting pipes or writing bad elevation, but it was not a realistic simulation. Okay, now we open the Epanet file of the last week, and we have to start to work on the options. We have to tell the computer that this time we do a simulation over the time. For this purpose, we have to go to the browser. Under data, you go to option and you click on times, like you see here. Doing like that, maybe you cannot see, let me check. You have this time option. You have pattern time step. Here, you have to put one number between 1 and I think 12. And this is actually the time that you consider for one changement of pattern. If you write 1, it means that every hour you have to give a different pattern. If you write 2, like in this case, it means that every 2 hours you change the pattern. If you write 6, every 6 hours, and so on. And then above, total duration, you have to give the hours that you want to do the simulation. If you do 24 hours, it's just one day. it's better to do at least 2 days. The reason behind is that if you do only 1 day, you start with, let's say, half full reservoir. Maybe you end at the end of the day with the empty reservoir, but in the morning, you start again with the full reservoir, half reservoir. So it doesn't really gives you a realistic simulation. That's why I like to work with 3 days at least, but you can work for 4 days. And then you can really see how the reservoir, how the system behaves over 3 days. So you use the water during 1 day, and the following morning, you continue with the situation of the previous day. That's why it's good to give more time. Then also you can give the time when you start the simulation, but it's not important. These 2 parameters, pattern, time step, and total duration are the most important one. And then again, you have to give the pattern. In this case, like I was telling you, we have 2 types of pattern. Type of pattern for consumption, demand pattern, and for the pumping time. So you go to the browser on the right, then we will see on the exercise. Then you choose under that a pattern, and here you will have this image here. You can see below here, you have 2 hours time pattern, because before in the option we have given number 2, and here you have the name of the pattern. We start with pattern number 1. You can put a description, for example, pattern for demand. And then you have to give the consumption in percent. You see here below on the right, I put, for example, for the first 2 hours, it means from midnight to 2 o'clock in the morning, 0.7 water consumption. After from 2 to 4, 0.8. I try to copy the consumption line here. Of course, you can change it. You can put 0.6. Important it is that you have, like I was telling before, the average must be 1. It means they are consuming 100 liters per day, for example, over 1 day. And this is very important. If you have a higher average, it means even if you know that the daily demand is 100 liters, but you have an average of 1.5, it means the system will consider 150 liters. So very important you put 1 here. You can as well save this demand for further use. And you give just the number up to 12 hours, 12 numbers, so that you will have the consumption over the 24 days. If you would have put a time pattern 1 hour, you should put 24 numbers here, not only 12. I think it's clear. We will see later how it works on the reality. Let me put again this one. Okay, now the issue is that you have to link each junction to the time pattern. We have some junction with the demand, and those junctions need to be linked to the time pattern number 1. So what you do, you go on the junction, you click twice on the junction, and then you will receive these tabs here. And here under demand pattern, you have to put 1, which is actually the name of the pattern that you have just created. And this for all the junction. You can do it automatically with bulk editing. I just switch very quick on Epanet to show how it works. Here, you have Epanet here now. You just go to edit, you go to select all, and then you go to edit, group edit, and then you choose the junction, replace the demand pattern with 1. Doing like that, if you have many junctions, you give automatically to all the junction the pattern 1. And of course, you can have a different pattern for different junction. In this case, we have only one pattern because we don't have industry, but you could have a situation where you have, of course, different pattern. Going back to my presentation. Okay. Okay, sorry, again to Epanet. Here now, if you check, let's say the junction, you will see you have demand pattern number 1. If I check junction 4, demand pattern number 1. I think it's clear. Okay, you do that for all the junction. And then you need to develop a second pattern, which is the pumping time. You have a type of pump that you probably have already identified. You know how much liter this pump can pump over 1 hour. You know how much liter of water you need for 1 day, and then you know how many hours the pump needs to run. If you have let's say 1,000, no, I mean, it's where the calculation is very easy. Knowing how much the pump knows to pump, then you just have to calculate the many hour. But the idea is now to know when the pump should work. So in this case, I say, okay, my pump attendant will start to pump at 8 o'clock and stop to pump at 2 o'clock in the afternoon, so 6 hours. And you see above, it starts here at 0.5, 100%, in this case 100%, 100%, 100%, and then it stops. Here, the average doesn't need to be 1. The difference is that the pump, once you switch on the pump, it works 100%. Once you switch off the pump, it's closed. So the average doesn't need to be 100% like in the demand pattern. As well here, you can save the pattern for further use. Again here, okay, average must not be 100%. Again here, now you have to link the pattern of the pump to the pump. Going back to my Epanet, I have the pump junction. I go to the pump. I click twice on my pump, and I see here pattern number 2. And this is very important. Otherwise, Epanet will not be able to link the pump to the pump pattern. Okay. Going back to my presentation. Yes, in case you have a solar pump, the pattern is defined by the sun and by your pump. And you have to try to recreate this, let's call it natural pattern. And in this case, you have to take in account several parameters. The solar pump works, of course, with the sun, and you know there is a big difference in the solar intensity during the seasons, the summertime and the winter time. So you need at least to do 2 patterns, one which reflect the situation during the summertime. This because you have more water during the summertime, more pumping intensity, and you need to check your system in terms of size of piping. So with a lot of water, how will react my reservoir? How will react the pipes? How will be the speed in the pipes? On the other hand, you have also to check the situation on the worst solarization, on the worst case in the winter time, when you have few sun, because here you have to check if the pump is going to deliver enough water for the population, if the demand is going to be covered for this population. That's why it's good to have 2 types of pattern, summer situation and winter situation. And of course, if you install a solar pump, you will have to do it professionally with a probably professional firm or organization who do that. And all this information are going to be provided based on your location as well. Like Lawrence, I don't know if you have Lawrence company in Syria, has a very good simulation software for solar pumping. Thanks to this simulation software, you will get all those information. Then once you have done that, you can run the simulation, and most probably you will get a message like that. And now it's time to check why we have such a problem. And first thing that you can do, check what happens in your reservoir. You open your reservoir, I show you how to do it. Let's say I run now the simulation here, and I have a mistake. Now we are live. What I have to do, oh, sorry, I don't want here, it is connected, negative pressure. Just let me move a little bit this one. What I do, first I check the situation on my reservoir. I click on the reservoir, sorry, take this one. I click on the reservoir and I go to this one. Here I have graph selection. I have T1 and I choose as a parameter the pressure. And now I see how the water behaves in my reservoir. You see, I start to pump in the morning at 8 o'clock for 6 hours, which is fine. And then there is a big demand and it's quickly dropping down and there is not enough water. That's why I have a problem here. And then it starts again and like that and like that. But you see, somehow I have a mistake here and I have to change my parameter. What can I do? How can I improve or correct my network? I can, for example, change the pump, have a bigger pump. I can, for example, increase the size of my reservoir, but in this case, though it wouldn't make any change because you see the reservoir never get really full. But what I can do, I can change the pumping time of my reservoir. Let's change the pumping time. I go here on pattern. I know that, sorry, I go here, source on pump, and I check what type of pattern. Pump was pattern 2. Okay, now I change the pumping, the pattern number 2. I don't want, it doesn't make sense. Here in this case, I was starting to pump at midnight to 6 o'clock in the morning, but it doesn't make sense to start at midnight. Let's start at 6 o'clock to 12 o'clock. Let's see what happens. So I change my parameter 0, 0. Here I start here 1, 1, 1. Now you see, it looks that I start at 6 o'clock up to 12. I change slightly the pattern. It's still pattern. I call it pattern number 4 this time. Okay, I save it. Yes. Now I have pattern number 4. Now again, I go on edit, select all, edit, edit, group edit, and I change, okay, the pump in that case, sorry, mistake. It was the pump pattern. So I have to go to pump, and I have to give to the pump pattern number 4, which is there already. Okay, fine. Now I've changed the pattern of the pump. Let's see what happens. And now it's successful. Just because before I was pumping during the night, but it makes more sense to pump over the day or during the time that people are fetching the water. Let's see now how our reservoir behaves. Again here, pressure. Now we see it looks much better. During the night, I don't pump anymore. There is a little bit demand. That's why the water in the reservoir goes down. Then it starts to pump at 6 o'clock. It go up, and then it's going like that. And now it seems to be fine. I could even decrease the size of the reservoir a little bit if I want it, because this is the elevation or the height of the reservoir is 2.2 meters more or less. So I would even save some money, but maybe it's not important to do that. But now we have to check as well different things. I want to see what type of pressure I have in my junction. Let's go back to the presentation. Where is it? Okay, here. So before in the previous case, it was not only that the reservoir was empty, but it was overfilled because it was only 2 meter high, the reservoir. So that's why you can improve the situation in changing the pattern or even changing the size of the reservoir. Okay. This is also a possible pattern that you could think. You could think even pumping maybe a little bit in the morning or a little bit in the afternoon. It's up to you. You have to find the optimum in terms of size of the reservoir, but not only, but as well in terms of working time. Maybe it's more convenient for you to have an assistant to pump 2 hours in the morning or 3 hours in the morning and 3 hours in the afternoon. This is up to you, but Epanet will give you the opportunity to make all this change. And again, I want to repeat that for every change that you do, you have to save the change so that you keep recording on all the changes. And at the end, you can really decide what is the best solution for your network. But now we have also to see how the pipes react, but especially the junction react. We want to assure that every junction has some pressure, enough pressure. What does it mean? At least if you have a tap stand, you should have at least 1 meter pressure. But if you have a house connection, depending on the type of the houses, you need much more pressure to up to 10 meters, depending on the houses. And maybe you have even too much pressure. In that case, you have to find a solution how to decrease the pressure. I was telling you, valves are not a good solution, but now let's go back to our live Epanet. It's here. To see the pressure on the junction, just click on the junction, go again on the graph. Why is not? Okay, here. You can even add other junction. I have junction 5 already here. This junction, I add it. And this junction I added. Now I have 3 junctions added on my graph selection. Again, I want to see the pressure and I click OK. Now I see how the junction, the pressure of the junctions behave over the day. You see, those 2 junctions goes up to 16 meter, which is a good pressure, but it's not too high. This goes up to 20 meter, probably still good. It's probably not too high, but it's fine. You see that you have everywhere, you have in this case enough pressure. If the pressure would be negative, the system would give you an error. And if the pressure is almost 0, then you have to be very, very careful because it might have a small change on the demand or on the pumping, whatever, and then you will have negative pressure, and this will mean no water in the pipe. And not having water in the pipe is not a good solution. And then also you can have a report. Here you can have the report table, column type, okay. You can see here table report of all the junction, the pressure that you have at one specific time. Again, report table, you give the time, or let's say I want to see the situation at 12 o'clock. And you see the situation at 12 o'clock. This helps you a little bit to understand the situation of your network. You can have as well a full report that you have everything, and this is going to be a Word document that you can save it and then open it and have a look. In this report, you will have all the data that you can analyze. You can have the flows of the pipes, the length of the pipe, everything is there. This can be interesting as well. You can as well check on the map the behavior of your network. You go on the browser, you want to see the behavior over time of the junction in terms of pressure. You look, and then you want to see the behavior of the pipe in terms of velocity of the water, for example. And then you see here a type recording style. You can start the simulation, and you see the color are going to change over time. You see here the time is running and the different color, and then you have the legend here, and then you really see the flow, the size of the pipe, and then you can see if you have a too high velocity, you might eventually increase the pipe. If you have a very high pressure, you will have a blue dot here. You might put the reservoir a little bit below. That will also save pipes length. But this also helps you to understand how your network behave over the time. And the simulation works over 3 days. We can run it, you can stop it, of course, and check all the details for every segment. And of course, all these elements can be exported and can be put in a report. Now, about the pressure, like I was telling you, in developing context or context with in war context like Syria, it might not be a good idea to put valves. That's why I don't like to have valves in the system, but pressure, sometimes pressure is too high. It might not be the case of Syria because you don't have high mountains, but it might be the case for Pakistan, for example. And that's why sometimes pressure reducing valves are necessary, but even that you might see on the picture, to reduce pressure, you can have an artisanal way to do that, just with a small reservoir, like in the picture is very clear. The water is coming in and just destroy all the energy through this, let's say, chamber, and then you really can decrease a lot of pressure on the pipes. And another valve that you have in the system that is always there is the control valves in the pipes. Or when you have here open, it means the water in the pipe can run in both directions. When you have CV, like in the picture, it's only in one direction. This might be interesting to put on the pipe after a pump, for example. But if you keep it open, of course, it's clear. Of course, if you put it closed, the system will not work at all. So that's a reminder about the valves. And that's actually all about the time analysis. It's once it is done, it's very easy to check it, to understand. The difficult part of it is really the part that we have discussed last week when you have to develop the workshop. Now I give you some time. If you have some question, it's time to ask. Otherwise, I will take another 10 minutes just to give you an idea about the problem of the elevation. Like you have seen, okay, maybe some question, please intervene if you have question anytime, just interrupt me. Like you have seen, the elevation is a problem because we normally don't have a total station, we don't have precise elevation. That's why I want to show you some ideas about how to find the presentation. There are several ways to find the elevation. You might use the GPS device or your phone. You might use topographic maps, online tools, a digital elevation model, and drone or total station. Let's start with the GPS. I don't know how many people of you are using the GPS. GPS is very good in terms of location, it's precise on the horizontal location, but for the elevation is really not a good tool. You might have up to 20-meter difference, and the elevation of the GPS also depends on the atmospheric pressure that changes over the time, over the day. So try to avoid to use the GPS. And if you have to use the GPS for any reason, try to take the elevation quick on during the same day. So you, at least you don't have a big difference on the pressure that influence your elevation. And if you use the GPS, try to calibrate before using the GPS, the instrument before starting to record the elevation, but avoid the GPS. Then you have Google Earth. Google Earth is fine somehow. The simple way, you just put the point of your location on Google Earth, and below on the right, you will have the elevation. It's fine, but as well, not that much precise. In some country, you might find topographic maps, like in Switzerland, topographic maps in Switzerland. In some country, you will find good topographic maps. I have no idea about Syria, how good they are, but if they are existing, please find them and extract the elevation through the topographic maps. In some country, you have even Cadastre available online, like in Switzerland. That's actually the best one because Cadastre are very precise. In my country, I have no idea about Syria. And forget about Africa. You don't have Cadastre, precise Cadastre. But then there is a new tools. Not a new tools, but a tools that I like to use because it's rather precise. It's called Free Maps Tools. I give you on the chat the link of that, but in the recording, it will be as well there. So this is a good tool because, okay, you just have to zoom in your location or give below the coordinates. Let's assume we have our location here, somewhere here. Just put the point, and then you have a rather precise elevation below here. And based on my, let's say, investigation, this was rather precise. But then I went through the comment this morning and I saw that for some people from some area is not very precise, but in my cases, it was good. That's a good tool. The link you have in the chat, and the link will also be on the YouTube channel as well. The only problem is that you need the precise coordinate, but this you can probably find, and you can also, that's a good tool. I like it. And then, of course, you have Globalmapper that we have seen in the previous workshop. If you take our exercise here, that's our small network. Let's take away Google Earth. Okay, I just show only the junction here. You select the junction, and then you download through the download icon, the digital elevation model. You go over the junction, you right click on it, analysis, apply elevation. And now all the junction, all those points got the elevation. You can check the information tool and you go here, you click on that and you see the elevation here. You see all the elevation. You see all the elevation, but be careful that this elevation is the terrain elevation. And then you have to consider that you have a still 1 meter top stand, or maybe you have a building that you have to connect to 10-meter building. So this is the ground elevation, but automatically you have all the elevation. And then additional with Globalmapper, it's interesting that you have also the pipes. You can as well look at the section of the pipe, and this is important. You select the pipe, you right click on the pipe, and you can see the profile of the pipe. This one, or maybe even all together, analyze pipe profile. Okay, then you see here the profile of your pipe. This is very important because at some point, for example, here you have a high point, you might identify the location where you can put an air valve or not, or a valve, a purge valve for cleaning the pipe. Based on the previous elevation, I put all the elevation together, and then I see that there is a big discrepancy between GPS and the SRTM model. So if I assume that my Cadastre is the most precise elevation, then I can really say that the free maps tool gives the best elevation. But this is for Switzerland. You should do the same exercise in Syria, and you should decide which way give the best elevation. But I wanted to tell you that the elevation is very...
Andrea, can I ask you some question?
Yes, please, go ahead.
Could we use the QGIS to measure the elevation?
Yes, you can use the QGIS, and actually I think it will be the topic next workshop, to see how to take the elevation from quantum Gs. But at the end as well, quantum Gs rely on the SRTM worldwide data, so exactly like a Globalmapper. So finally it is, yes, you can use quantum Gs, no problem, but it's not very precise. The best definitely is this total station and the drone, but not always possible. And on the other hand, if you have enough energy, it means if there is slope enough, you shouldn't be too much afraid, because there is energy. The problem is only when it's rather flat, where you don't have energy. So where your reservoir, let's say, it's only a few meters above the tap stand, then yes, you have to be very carefully. But you have a 20 meter of pressure or 40 meter of pressure, it's no problem. And in Syria, not always you have hills. Sometimes it's flat, and in that case, it's really advised to use the total station to get the precise relative elevation. Next Tuesday, there will be a workshop about Epanet, georeferencing Epanet with quantum Gs, and also with paper maps in the paper. And we are going to see how to import digital elevation model in quantum Gs, and how to automatically draw Epanet file in quantum Gs. I think it's finished. I told you it is short today. If there is any other question, please go ahead. Like usually, this presentation is going to be recorded. By the end of the day, you will have the English version on YouTube, and one day as well, the Arabic version. And you will get the link for the third part of Epanet, which is georeferencing Epanet with quantum Gs, and georeferencing Epanet with paper. Why it's important to be able to georeference Epanet with a paper? Because in some cases, you might have to work on an existing network which is only on a paper, not digitalized. And the mayor of the village gives you the network on a paper and tell you, okay, that's the situation, please do it. And then you have to somehow find out the length of the pipe and the situation, and through a paper map. That's all for today. If there is any other question, please ask it now. I see you on Tuesday next week. We will do it Tuesday at 3 o'clock. But you will get the link before. Thank you for your time.
Thank you, Andre.